Hi there everybody. This video is to help you walk through the table in the third CrystalMaker assignment. And just to be clear, that is this table hanging out under this figure here. And so what we're doing in this part of the assignment is we're going to be taking some bond lengths and some bond angles, averaging them, and then you all will be reporting the coordination number and then estimating the temperature and pressure ranges of these various silica polymorphs, which are listed here. I've just highlighted them. So these three columns are for you to do. I'm going to do this first row for alpha quartz here. Okay, so if you don't want to search all of these individually in the CrystalMaker library, you can download the files, click the hyperlink here, and that will take you to a folder. You can download them, put them in a place that you know how to find them on your computer, and then you can just open them up one after the other. Or just search them in the CrystalMaker library. Okay, so like I said, I will be showing you how to calculate the average bond lengths and average bond angles for alpha quartz. So I have alpha quartz pulled up in CrystalMaker. Here it is. So for this part of the assignment, we're going to be using a tool that we've not used yet. That is the bond length tool, or the bond distance tool, which we get to by pressing the D key on our keyboard, or the bond angle tool, which you press the letter G, as in giraffe, and that was D as in dog for the distance. So angle, G, distance, D. Okay, but to measure bond angles and lengths, we're going to need to see the model in ball and stick. So I'm going to press Control 1. Remember, you can also go to Model and then choose your model, but we're doing ball and stick. All right, so when we're calculating the average bond lengths and bond angles, we need to be careful about which tetrahedron we choose. So for example, if I put one of these ones in the edge in the center of the screen, so like this one here, you notice that it's not complete. It only has, it's an oxygen pointing to a silicon. Even these ones that are out here, it has an oxygen and two silicons, but that's not what we want. We want one of these in the center. So for example, this one here, this silicon in purple, has 1, 2, 3, 4 bonds coming off of it, right? It's not connected to that other silica. It's only connected to these oxygens. And so to sort of declutter the screen, I'm going to try to bring this down to 1 unit cell by just going to range and then clicking cell contents. So perfect. I have one of these tetrahedrons. It's got 1 silicon with 4 bonds sticking out to the oxygens. Okay? So let's get into it. We're going to use the bond distance tool. And what we do here is we click on one of these atoms and then trace to a new atom. So we can click on oxygen and then trace over to the silicon, click again, and now that length is all is made up. But unfortunately, if you mouse over another atom, it disappears the bond distance. I don't know why, so just be careful there. But anyway, click that, kind of put your mouse off somewhere that it's not going to touch another atom. We can see that my bond distance is 1.613 angstroms. And so to help me out with my calculations, I like to use Excel for a lot of stuff. So I'm going to pull up Excel. I'm going to have my lengths here. And then I know I have 1, 2, 3, 4 lengths to measure, right? Because we have 1, 2, 3, and 4. So let's measure that again because I've deleted it. 1.613. So 1.613. My first length. So I've done this one off to the left. Let's go up and down. That was also 1.613. Great. Go to the right, 1.605, a little different, 1.605, and the fourth one down is 1.605. Okay, now if you don't know how to do sort of basic math in Excel, the way you do that is you type in an empty cell, you type in an equal sign, and now it's ready for you to put in a formula. And all I mean by that is you're going to type average and spell it correctly, unlike me. So you can see I've typed the first few letters of average. It said, do you want to do average? And I say, yes, I do. So I'm going to hit tab. And now it's ready. It just needs me to feed it some numbers. So I click on the first cell and I drag down. I select all 4 of the ones that I've entered data into, and then I just hit enter. There's my average bond length, 1.609. So I'm going to fire up my document again. 1.609 is the average bond length in alpha quartz. Now how about bond angles? What we're going to do there is not go to Excel. We're going to go back to CrystalMaker, and then we're going to use this the tool where you can press G and select it, or just click it there. This is the bond angle tool. And this, like the angle tool in the last video, requires 3 clicks. So we're going to click on one atom, another, and another. And that's the angle we want to measure. We want to go from oxygen to silicon to oxygen. Notice in the document, which is not the Excel file, it tells you right there, O to Si to O. Okay? So back to CrystalMaker. We'll do this one here. 108.873. 108.873. So we're going to go to Excel. These are my angles. And I have 1, 2, 3, 4 of them to measure. 108.873. Okay. Next angle. Click on an oxygen, silicon, oxygen. 110.557. Okay. Next one. Oxygen to silicon to oxygen. 109.266. 109.266. Finally, oxygen, silicon, oxygen, 110.557. All right, and the same thing we did before. We're going to type equals. Start typing average. It pops it up for us. I say, yes, I want to take an average by hitting tab. Select my 4 values. Hit enter. 109.8133 is my answer. So that is 109.8133. So that's how you calculate the average bond angles. So as I said at the start of the video, we're leaving coordination number and then the approximate temperature and pressure ranges up to you. For these 2 columns, make sure you're reading off of this diagram up above, and you can read the instructions in this paragraph here to help explain that more. Again, as it says at the end here, just do your best. It does not have to be a pixel perfect approximation. Just give it a shot. But one caveat I need to bring up is this coesite mineral down here is a little funky, and I'll show you why. So I'm gonna bring alpha quartz back up, and we'll put it off to the side, and next to it we'll compare coesite. So coesite's on the right with this black background, and alpha quartz is on the left. So I'll turn back to polyhedron view. And so what you'll notice is that the alpha quartz only has 1 silicon site. All the silicons are in this same configuration. They're in this 1 silicon site. Whereas in coesite, there are 2. There are 2 silicon sites. You can see them here, T1 and T2, they are labeled. And you see that they are sort of light blue and purple, respectively. So what that means is that on coesite, you'll have to take the average bond lengths of one of the blue ones, and then the average bond lengths of a purple, and average them, and then average those 2 values. And the same thing with the angles. One average of the T1 angles, one average of the T2 angles, average those values. And that's what you'll report on your sheet here for coesite. Okay? Hope this was helpful. I'll see you in the next one.